person making the noise on the video is Sia. Okay. We are busy with exercise 7. I want us to do just a couple of them together, because this is still basically grade 10 work, so that we can get to the grade 11 equations. So the first one we're going to do is A. It's 3 to the power of x equal to 1. So when we have an equation, especially with exponents, we want to have a base and an exponent, a base and an exponent, then the bases are the same, we throw it away. But when I look at 1, I want to try to get 1 in terms of 3 to the power of anything. Well, that's right. So 3 to the power of x is going to be 3 to the power of 0. That works with 1 with any base, right? Now the bases are the same, you throw them away, so x is equal to 0. Two to the power of x equal to the square root of 2. Who can tell me what can I do there? What's the root? 2 to the power of x equal to 2 to the power of half. And then x is half. Stadiger. Next one. A 9 to the power of x equal to 27. And I'm going to give you a minute to do it yourself. Okay, what I did at D, a 9 is 3 to the power of negative 2. Remember, I want to have a base and an exponent. So it's 3 to the power of negative 2, because 9 is 3 to the power of 2, and then I take it up, it becomes negative. 27 is 3 to the power of 3. My bases are the same, so I can throw them away. Then I just take the negative 2 over and divide it. Did you get it right? Okay. At E, I want you to make a note next to E. And this is not really something difficult at E, but going forward, I saw now with the other class as well, they forget this. Only exponential can multiply or divide with exponential. You know that, no? Only a normal number can multiply and divide with a normal number. And only a surd can multiply and divide with a surd. You cannot multiply a normal number with a value that's in exponential form. So when I look at 16 times 16 to the power of x, 16 is a normal number. 16 to the power of x is exponential. 64 is a normal number. So what do you think we're going to do? Divide with 16 so it can go to 64. Here it cancels out, right? This is mathematically what we're doing. And here 64 divided by 16, that gives me 4. How can I now get them to have the same base with an exponent? Okay, now there are two ways that you can do it. Some of you might say, I'll make this 2 to the power of 4x, and then this one 2 to the power of 2, that's fine. Others might say, I'll make this 4 to the power of 2, and leave this one 4 to the power of 1. Both cases will give you an answer of a half. So it doesn't matter which one you choose. Right. I'm just going to make this 4 to the power of 2x equal to 4 to the power of 1. Bases are the same, throw them away. X is equal to a half. So I divide it with 2. Do you understand that, everyone? Yes. Do you understand, Relu? Can I page? Okay. If this was an expression sum, let's pretend there's no equal to sign. What would we do to start with this sum? We would what? This is it. We take them to prime factors. We cannot divide with anything unless we divide with exponential thing, and then one of them will disappear. Anyway, I have it this side, it's not going to work. But the problem is they're not prime. So how am I going to write 8? 16, 2 to the power of? Can I sommaklaar multiply the 4 in? So it's 4x minus 4. Now, when you were here the previous period, I said to you, the skills that you learn with the expressions is what you must apply with the equations. And this is what I meant. If you were going to put it in prime numbers with expressions, then that's a good place to start with equations. Don't now go and do funny things, like dividing with a number when the one is exponential. Stick to the skills that you've just learned. I can do something here, ne? It's 2 to the power of 7x minus 4. Now what does, this is very important, what does this minus 4 thingy mean there? What is it? It's 2 to the power of negative 4. So when that number is just a number, it doesn't have a variable in it, do you realize that it's actually just a normal number? It's a number. Guys, because 2 to the power of negative 4 is actually 1 over 2 to the power of negative 4, which is 1 over 16. It's a fraction, it's a number. Now I'm going to put in that step so that you can see it. It's going to be 1 over 16. Normal number. So this one, exponential. This one, normal number. Even if it's a fraction, it's a normal number. This one, normal number. So what do you suggest we do now? Take the 1 over 16. Now there are two ways of doing it, but if you say you're going to divide with 1 over 16, sometimes you guys, not you guys, we all get confused, because now you are going to divide with the 16th and then it becomes a whole complicated thing. Because dividing with a fraction, you have to remember to change to multiply and swap around, blah, 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 blah. You remember those things. So an easier way just to do it is to say you multiply with the reciprocal. Okay. Because that's going to sort it out. If you multiply with 16 over 1, you multiply with the denominator basically, it cancels out. But then you must just do it here as well. But then you don't have to go and think about dividing a fraction, blah, 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 blah. Okay. So if you want to get rid of a fraction of a denominator, you just multiply with the denominator because then it cancels out. Happy with that? So now I'm left with 2 to the power of 7x equal to 1 times 16 is 16. What am I going to do with 16? What's it? Bases are the same, ne? So x is equal to 4 over 7. Now I'm going to give you just one more. I want you to help me think of a plan that we can do here. There are 6 of them. Says. Just think of a plan. I want anyone to give me a plan. Factorize. How do we? What would we do? 6 to the power of x. Okay, we keep that in mind. Any other plan? Okay, she's got the plan. She says you add all the x's, therefore it would be 6 to the power of 6x. Is that what you're saying? Okay. Alright, let's consider. One option we have is 6 to the power of x. Adding the x's to get 6 to the power of 6x. Now the reason that won't work is because it's plus. If it was multiplication, then we would do that. Now, we have the solution. It's just a different way of saying it. So she said we should take out something in common. Why did you think we should take out something in common? Isn't it because you saw the plus maybe? No? You guys remember when we see a plus or a minus, we take out something in common. The only difference is now we're not just adding 2. We are adding 6 of them. But it doesn't matter, you can do that. What would you take out? 6 to the power of x. What would remain? 1 plus 1 plus 1 plus 1 plus 1 and plus 1 equal to 6 to the power of 6x. And then what would that be if you add them? Okay. Now that is perfectly correct. The other way you could see it is, remember when we learned about adding algebraic terms, we would say if the base and the exponents are the same, you add the numbers in front. So you could have just said as well 1 plus 1 plus 1 plus 1 plus 1 plus 1 is 6, 6 to the power of x. Doesn't matter how you see. But the important thing I want you to see in this sum is that we so easily make the mistake of applying multiplication rules when there's a plus. You must remember the addition and subtraction rules and remember the multiplication rules. Right. Now, that was the main part I wanted you to see, and you guys did very well to understand it. If you look at this, do you see now you've got normal number, exponential, exponential. two ways of doing it. You can either now divide with 6 to the power of x. Then you would have 6 equal to 6 to the power of 5x because of the subtraction when you divide it here. And then you'd have x equal to 1 over 5. Dividing with the 5 on that side. The other way you can do it is from there to say, right, that exponent is 1. I'm making it exponential because then my bases are the same. Then I've got 6 to the power of 1 plus x equal to 6 to the power of 6x. And then I have 1 plus x equal to 6x, which also, if you take that one over, minus it, I also end up with 5x equal to 1 and x is equal to a fifth. But as I say, the main part I want you to see here is what we do when it's addition. Then we add the coefficients or we take out something in common. Not add the exponents. What? Must I go through it again? What? Daar. More. More. Done. Okay. Now we're going to get to the grade 11 work. I want you to write example 1. This is still equations. Example 1, come. All right, grade 11s. A week or two ago, when we started with this, we would just have given you that part. Okay. Now it's equal to an answer, so we have to find the value of x. But as I said, we now have to use the skills we learned from expressions to be able to solve the equations. Now, if this was an expression, what would you do? How would you start? Prime number. No, 9 is not right. I would say it is 3 to the power of 2x plus 3 to the power of 2x, and we can leave that 3 to the power of 1, but I think we could rather take it to, not leave it plus 1, we could take it to 3 to the power of 1, which is just 3. Now I'm just going to leave that part there now. Now if this was expressions, then at this stage we would see that we have two terms. And then what do we do when we have two terms? We can take out something in common. What do we take out in common? And then what would remain is 1 plus 3. And that would result in 3 to the power of 2x times 4. And that was up to where we could do it when it was an expression. Yes, you can write it. But then we would be done. Now they have given us an answer. Equal to 4 root 3, equal to 4 root 3, equal to 4 root 3. Now do you see, now we can take it a step further. I've got exponential, I've got normal, I've got surd. But surd can be exponential, no? Alright, so what am I going to do? Can I divide by 4? Both sides. Yes, remember my plan is to have a base and an exponent. A base and an exponent. So these normal numbers are bothering me. Don't want them there. So I can divide by 4 and divide by 4. Because this is an equation. I just have to do the same thing everywhere, then I haven't done anything. I said now it's an equation. We can move. Now it's 3 to the power of 2x equal to, what is root 3? 3 to the power of a half. My bases are the same. I can throw it away. Then x is equal to a quarter. Why are you looking confused? No, I said when they say prove that this is equal to this, then you don't touch this side. This one I said solve for x. You remember? Okay. I'm going to show you one now where you mustn't touch the other side. So yeah. Shouldn't it be? No, it's not 2 divided by half, it's a half divided by 2. Okay? It's fine, you can write example 2. Here is Sia's sum. Sia, now the instruction says that you must prove the left hand side to the right hand side. Therefore, this is not an equation. This is still an expression. All they've done is they've given you the answer of this expression in its simplest form. Right. So when I work with this side, I'm not going to use that side. If this is the expression, what can I do? There's a plus. Take out something common. What am I taking out? What remains is 5 plus 3 times 2 to the power of 2. You know where I got the 2 to the power of 2? Yes. Okay. What's 3 times 2 to the power of 2? 3 times 4. Did one of you just say 6 to the power of 2? Huh? Bodmas. First exponents, then multiply. 2 to the power of 2 is 4. 4 times 3 is 12. 12 plus 5 is 17. What did they give me on the right hand side? So now I can say left side equal to right side. Okay. Now this would normally be question A, and then there would be a question B that starts with hence. You know what hence means? Alright, let me explain to you what hence means. Hence means because of what we just saw here, because of what is given here. After seeing that, now use that to solve for x if they tell you that that expression is equal to 68. Now let me tell you what you guys always do in an exam. Many times learners aren't able to prove the left side equal to the right hand side. Okay, then you get something totally different. Then they go to the hence question. Then they take this expression and try to redo what they already saw they couldn't do. So they redo it wrong and try to solve it now. Okay. What they're doing in this question is they are giving you the answer of this thing. What does equal to mean? It means whatever is here is the same as what is here. So even if or whether you couldn't simplify that to its simplest form, if you have a hence question, you use the simplified one. Don't go and redo the wrong you already did. And even if you got it right, don't go and redo the work you just did. You have the simplified answer. You don't go and prove it again. Now, instead of taking that, this is equal to 17 times 2 to the power of x equal to 68. Now you solve it. Do you understand? That's what hence means. Now use what's above. Alright, now you divide 17 on both sides, and then 2 to the power of x is equal to 4. 2 to the power of x is equal to 2 to the power of 2. X is equal to 2. Hence, remember for hence. Write this down. Okay. This is very important for the type of sums that we're going to do now. If you look at the terms that has the x in it, if it has the same exponent, so the one is x and the other one is x, or the one is 2x and the other one is 2x, or the one is negative 10x and the other one is negative 10x, then it's the same. Then you take out something in common like we've done up to now. And we want it equal to a number. Must be equal to 10 or whatever, like we had here at hence. You see? You took out something in common and it's equal to a number. That's what we want. But now we're also going to see that it can happen that the one exponent is double the other exponent. Now when the exponent is double the other exponent, it means it's a quadratic equation. So it's like x squared plus 2x minus 3. Remember those? Quadratic trinomial. The one exponent is double the other exponent. Then it's a quadratic equation. Then it must be equal to 0. And then you're going to factorize. You know Haki factorization? Yes. No? And then you can also have a quadratic equation where you also just take out something in common, but then there will be an x inside still. With these ones, when we take it out in common, there's no more x inside. But when it's quadratic, one of the x's will stay inside, so it must still be equal to 0. Okay, keep that in mind. Example 3. Look at this exponent, it's to the power of 2x. Look at this exponent, it's to the power of x. Is this and this exactly the same? Is this double this? Yes. So in other words, it's a quadratic equation. Can I multiply the 6 with the 3? No, 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 no. You should have said no quicker. Normal number, exponential. Okay. The other thing that we wrote that quadratic equation is that it must be equal to 0. If these two were the same, I would take the 27 to the other side. Because the one is double, the other is quadratic, so I want it to be equal to 0. These are things that you must know. Okay. Now I want to show you another sum before we do the sum. Would you be able to do this one? X squared plus 6x minus 27 equal to 0. What will it be? Haki haki, ne? What will this be? This? How did you get that x? Square root, ne? It's just square root of that one. And then here and here? 3 and 9. Because the factors must subtract to get 6. Will it be plus or minus? Where will the plus and the minus be? Minus 3 plus 9, because plus 9 minus 3 will give you 6. Okay, always be sure of your signs. And then you would say x is equal to 3 and x is equal to negative 9. Okay, back to that sum. 3 to the power of 2x plus 6 times 3 to the power of x minus 27 equal to 0. Would you believe me if I tell you that this is exactly that sum? This one is that one. The only difference is when you take x squared square root, it's x. When you take 3 to the power of 2x square root, remember it's the exponent divided by the root number, so it's 2x divided by 2. It's 3 to the power of x. 3 to the power of x. Did I use the x any further after just taking a square root? After that, I just used the constant and the coefficient. That's all I used. So why would the rules change? What's the secret to mathematics? Everything stays the same. So after I took that square root, factors of 27, that will give me 6 when I subtract them. 3 and 9. Will it be plus or minus? Minus 3 plus 9. Now my answer is 3 to the power of x equal to 3. 3 to the power of x equal to negative 9. Okay, now it looks like the sums that we did in exercise 7. Now we just need, remember we haven't found the value of x yet. It's just one small step more. This one, his bases are the same. So x is equal to, can I write, okay, let me ask you this. Can I write 9 as 3 to the power of something? 9. 9. 3 to the power of 2. Can I write negative 9 as 3 to the power of something? No. Okay. Negative 9 cannot be written as 3 to the power of something. It's negative bracket 3 to the power of 2, but that's not the same as 3. Is there a difference between having $1 million and having negative $1 million? Yes. If you have negative $1 million, you still need $1 million before you have nothing. Okay, big difference. So this one will have no solution. But understand why. Don't just decide anything, anywhere where you get a negative, it can't be a solution. This has no solution because negative 9 cannot be written as 3 to the power of something. Okay. So is that hard? No. But if you look at these sums, it looks hard. Let's look at A. Take out something in common or quadratic? It's 3 to the power of x and 3 to the power of x. It's something in common. The second one, it's x and x. Common. X and x. Common. That one they already took out. You can take out some more, but we're not going to look at that one. This one, E. 2x and x. Quadratic. Because it's double. Yeah, I think in all the textbooks it must be. No, that minus must just be there. Okay. This one now has a 2 times 3 to the power of x plus 2. What does that plus 2 mean again? Do you remember? It's a normal number. So it's actually 9. Ne? So this one has 2 coefficients. It's got the 2 and the 9. Then you just multiply them off with each other. So it's actually 3 to the power of 2x minus 18. 3 to the power of x. Because it's that 2 times that normal number. So it's not in standard form yet. And then there's your constant. Do I want to take the constant over? No. Quadratic equal to 0. This one? 2x and x. Quadratic. G. Prime. She says prime first. 2 to the power of 2x. Then it's quadratic. You understand? You see? Don't forget the skills you learned at expressions. Okay, this one H. The same or quadratic? Prime and then it's quadratic. Okay. This one? Common. 10 to the power of x, 10 to the power of x. This one, there's a negative x and a negative x. Common. That is even if it's negative. If it's the same, it's common. If the one is double the other, it's quadratic. Okay. So, what you are going to do for homework for me is exercise 8. Page 13. No, relax and be quiet. A. E. Sorry, no. A, E. F. H. And I. 1, 2, 3, 4, 5 sums. Either common, then equal to a number. Or quadratic, then equal to 0. You factorize. Okay. Tomorrow, after we've marked this, I'm going to give you more of this. And sweets, you say. Let me just stop that. Alright. Guys, remember, if you are going to do this afternoon,